Hello everyone and welcome to my channel CloudOps DevOps. In this video, we will see an introduction to DevOps, difference between CloudOps and DevOps, and collaboration between CloudOps and DevOps. So before starting, this is a short introduction about myself. My name is Kanchan Kumar Das. I have 7+ years of IT experience. I have worked in 2 reputed organizations till date. I have been a part of technical recruitment team and I have also provided cloud training to external training institutes. I have worked on Azure infrastructure, Azure services, Azure networking, Azure DevOps, Kubernetes, Git, Terraform, ARM, and Bicep. I have completed certifications in DevOps engineering, Azure Solutions Architect, Azure Network Engineer, Azure Administrator. I have also completed DevOps engineering certification from Edureka and Kubernetes Administrator certification from Edureka. So let us see that what is DevOps. So the full form of DevOps is development and operations. Many years back, project development used to take place, or software development used to take place with the help of a methodology called the waterfall model. Now, as the name suggests, waterfall, it was a unidirectional methodology. So every process would happen only when the previous process or the previous phase has completed. It used to start with the requirement gathering phase, then came the documentation phase, then came the designing phase, then came the development phase, then testing, and then the production go live, and then the monitoring phase. Now, testing could not be started unless development was completed, or development could not be started unless the designing was completed. Also, this methodology didn't have much space for frequent changes requested by customer. So, say for example, if a project is being developed with waterfall model with a timeline of 2 years. Now, within these 2 years, the customer would not have any visibility on the product. So after 2 years, when the product was delivered to the customer, at that time, the particular technology on which the product was developed has already become obsolete. So now the customer wants the product to be developed in mobile mobile technology, or maybe the customer wants some other technology on which the product can be developed. However, it is too late to accommodate this level of changes in the software development process. Therefore, this waterfall model didn't prove to be much of use. Then came the agile methodology. Now, agile methodology bridged the gap between development team and the testing team. The developer team used to develop code and they used to uh, deploy it in a particular environment. Testing team used to test it from the QA environment. They used to give feedback to the development team, and the development team used to accommodate those changes in the code. Also, the customer used to get chances to test the code from the QA environment, and they used to provide feedback to the development team, and the changes were included. So this bridged the gap between the development team and testing team, which ensured error-free delivery to a large scale. However, the deployment of code in various environments, for example, in the UAT environment, in the QA environment, and in the production environment, was done by the operations team. The packaging of the code, the transportation of the code was, or the monitoring of the application was all done by the operations team. But in the agile methodology, the operations team works in isolation. They don't have any communication with the testing team and the development team. So the conflict that used to happen is the operations team, after deploying the code in QA or pre-prod or prod, used to complain that the code is not working in the higher environments. However, the development team used to uh, used to argue that the code is working in their personal laptop. So that means there is some problem with the higher environments provisioned by the operations team. So this conflict within the development team and the operations team used to happen. However, this gap between the development team and the operations team was bridged by DevOps. So DevOps uses agile methodology. We can call DevOps as an upgraded version of agile delivery process. So DevOps bridge the gap between the development team, the testing team, and the operations team. So now the development team used to continuously develop the code, continuously build the code. Testing team used to continuously test the code. The operations team used to continuously deploy the code. So in DevOps methodology, as the name suggests, that DevOps, and also as it is written that DevOps is a culture and it's a software development methodology. So DevOps is a culture in the sense that the traditional uh, culture of the development team, testing team, and the operations team working in silo was actually totally removed. And in DevOps methodology or DevOps culture, the DevOps team, the testing team, and the operations team were all brought together and they started working together. That ensured continuous development, continuous building of code, continuous integration, continuous testing, continuous deployment, and continuous monitoring. The customer was given chances to test the application, to test the features at every phase of the development. They used to provide their feedback, and that feedback used to be uh, fed back to the development team. They used to accommodate those changes in their code, and again it used to be deployed to the higher environments by the operations team. Frequent deployment of features was enabled in DevOps, and so the customer could get a chance to test the code and provide their feedback frequently. So this ensured that all the teams, the development team, the testing team, the operations team, and the customer are all on the same page at each point of development. Now, in my previous video, I have given introduction about the cloud ops. Here we will see what is the difference between cloud ops and DevOps. So as I said in my previous video, that cloud ops takes the responsibility of provisioning the infrastructure, the services, the security features, the policies required for the developer team to develop their cloud-native applications. So if so for example, imagine a developer team who wants to develop event-oriented and event-triggered solution using cloud-native technologies, and they need an event grid, they need a service bus, they need a key vault, they need a storage account, they need a logic app, and they need Azure functions for developing the solutions. So they will come to the CloudOps team and they will request them to provision it. CloudOps team will provision these infrastructures following the best practices, either with the help of Portal or with the help of any infrastructure as a code, for example, Terraform or Bicep, and they will provision that infrastructure and hand it over to the development team. The development team will just use those services and products to develop their solution. That is the responsibility of CloudOps team. Now comes to DevOps team. So what is the difference between CloudOps and DevOps? CloudOps is responsible for provisioning the cloud services and infrastructure for developers to build their cloud native applications, whereas DevOps team is responsible for building and deploying and monitoring applications developed by developers. For example, the developer team wants to develop an Azure function. Now, Azure function is a platform as a service provided by Azure where developers can host their .NET code. Now they need to actually write their .NET code before they can host it in the Azure functions, or before they can host it in an app service. So an Azure app service is a platform as a service where developer team hosts their web applications. However, they need to write down that C# code to host it. So that source code is developed by the developer team, and building of that source code, performing static code analysis on it, performing any sort of security scanning of that code, creating artifacts, deploying that artifact to the app service plan or to the virtual machine or to the Azure Container Registry or to the Azure function or wherever the developer team wants their code to be hosted. That building, deployment, and monitoring is done with the help of the DevOps team. So the DevOps team is not bothered about the provisioning of the infrastructure. That has been done by the CloudOps team. The DevOps team is concerned about building and deploying the code developed by the developer team and putting that code into the place where the code needs to be hosted. The next difference is cloud The next difference is the CloudOps team automates infrastructure provisioning, whereas DevOps team automates application build, test, deployment, and monitoring. So CloudOps team is totally concerned about infrastructure provisioning, maintaining of the infrastructure, monitoring the infrastructure, ensuring that best practices are established while deploying the infrastructures, continuously monitoring the security score of the infrastructure, all these things. Whereas DevOps team is concerned about building and deploying the source code which is developed by the developer team, and the code that they are pushing in the Azure and in the code repository. So that code repository can be Azure Repos Git, or it can be GitHub or Bitbucket. So the DevOps team automates application build, test, deployment, and monitoring. The CloudOps team leverages monitoring tools such as Azure Monitor, Microsoft Defender, Azure Sentinel for monitoring cloud services. Yes, so uh, in Azure we have various security as a service. For example, Microsoft Defender is there, Azure Sentinel is there. So Azure Sentinel, Microsoft Defender, these actually continuously monitor the infrastructures in a particular subscription, and it keeps on providing recommendation. It keeps on providing security alerts to the cloud operations team, which they need to follow to increase their security score. Microsoft Defender provides something called a security score, which shows that how secure our applications are. So the more we try to improve our security score, the more secure our application gets against various type of cyber attacks. So CloudOps team leverages monitoring tools such as Azure Monitor, Microsoft Defender, Azure Sentinels, whereas DevOps team leverages monitoring tools such as Azure Monitor, Prometheus, Grafana for monitoring application health and the services in which the apps are hosted. So that is the difference. Now, how do CloudOps and DevOps team collaborate among themselves to achieve the highest level of security in the cloud services and to leverage the cloud features? Here is a scenario I would give. Say for example, there is a developer team who wants to uh, use cloud services, for example, Azure Event Grid, Azure Service Bus, Event Hub, Key Vault, Storage Account, various types of Azure services they want to provision for building their cloud-native applications. So they will reach out to the CloudOps team and request them to provision it. CloudOps team will follow the best practices for provisioning this infrastructure. That means they will not provision it with the help of portal. Always remember that it is the best practice to provision cloud infrastructure is with the help of infrastructure as a code, not with the help of portal. So the CloudOps team will create a Terraform script where they will include all the services that are requested by the developer team, the RBACs, the Azure policies, the all sorts of VNets, VNet integration, subnet integration, all sorts of private endpoints, everything they will write in detail in the Terraform script. So after the Terraform script is developed by the CloudOps team, now what will they do? They will hand over this Terraform script to the developer team. Now the developer team will go to the DevOps team, the DevOps, and request them to deploy their script so that the Azure services gets deployed. Now the DevOps team, what they will do, the DevOps team will create a Git repository where the developer team can push their Terraform script. So that Git repository along with the branching strategy will be prepared by the DevOps team. Now once the Git repository is prepared, the developer team will push the Terraform script into the Git repository. Now the build and deployment will start. So the build pipeline and the deployment pipeline will again be created by the DevOps team. So once the Terraform script, which has been developed by the CloudOps team, is pushed into the Git repository, the build pipeline and deployment pipeline starts its execution. The Terraform script is built and it is deployed. Deployment of Terraform script means all the Azure services gets deployed in its specific resource group. After it is deployed, now again the responsibility goes back to the CloudOps team to start monitoring those Azure infrastructure. So the CloudOps teams start using Microsoft Defender, Azure Sentinel, Azure Monitor to monitor the Azure infrastructure that they have deployed. So this is how the CloudOps team and the DevOps teams can collaborate among themselves to continuously build, deploy, and monitor the cloud infrastructure. I hope I could make this slightly clear about the definition of DevOps, why DevOps has come into picture, and what is the difference between CloudOps and DevOps. What is the collaboration? How the CloudOps and the DevOps team collaborate among themselves. Uh, I would be keeping this much only for this video. If you have any questions, please write it down in the comment section. I will try to answer, and I will come up with much more fundamental concepts in my next video.